Welcome. This is Form 4 Mathematics and the topic today is area approximations, and you're going to look at trapezoidal rule and the mid-ordinate rules. The question reads, complete the table below for the curve y is x squared minus 3x plus 6 for the range -2 to 8 for the values of x. So the table is as shown. Then part B, use the trapezium rule with 5 strips to estimate the area bounded by the curve y is equal to x squared minus 3x plus 6. The lines x is equal to -2, x is equal to 8, and the x-axis. Then part C, use mid-ordinate rule with 5 strips to estimate the area bounded by the curve. The line x is equal to -2, x is equal to 8, and the x-axis. And then part D, we are going to determine the exact area by integration. The area bounded by the curve, y is equal to x squared minus 3x plus 6. The lines x is equal to -2, and x is equal to 8, and the x-axis. So, write the solutions. First, we are going to fill the table. Let's complete the table for the given range of the values of x. So if x is -2, what will y become? So we simply substitute the values of x in the function y is equal to x squared minus 3x plus 6. So that for the first one, we have 16, then 10, then 6, here we'll have 4, then 4, 6, 10, 16, 24, 34, and 46. So, for part B, use the trapezium rule with the 5 strips to estimate the area bounded by the curve as shown. So, I'm going to have a sketch of this. Remember, for this particular case, we have the coefficient of x squared being positive, so we have the curve being of that particular nature. So if this is the Cartesian plane, then so it's not right here. What you're simply going to have is, if here we have -2, if we have -2 right at that point, then we want to partition it into different trapezia. But before we do that, we need to know the width of each trapezia, the width or the height of each trapezia. So for each trapezium, we get that h is equal to, so we determine the value of h by having the extreme values, 8 minus -2, which is just 8 plus 2, and then you divide by the number of strips, which is 5, and that should give us 2. So from -2, we move 2 steps, and that takes us to 0, then 2 steps again, 2, another 2 steps, 4, next 6, and finally we will have 8. So that we have 1, 2, 3, 4, 5 strips. So we're going to get the values of y when x is -2, y when x is 0, y when x is 2, y when x is 4, y when x is 6, and finally y when x is 8. So all these values, we've already obtained them up here, so we're just going to pick them. So for trapezium rule, we're going to say that area is given as a half times the height into the sum of all the parallel sides, so that we first of all have the extreme ones, y -2, plus y 8. That is the first one and the last one, and then the middle ones will have to double each one. So twice y when x is 0 plus y when x is 2 plus y when x is 4, and then finally plus y when x is 6. So doing our substitution correctly, we are simply going to have the area as a half times h, and h already have as 2, into the first and the last one, that is 16 plus 46. Then we will have to add that to twice the middle one, y when x is 0, that is 6, plus y when x is 2, 4, plus y when x is 4, 10, plus y when x is 6, that is 24. That is it for that. And then the next, when we work this out, we realize that the area under the curve is 150. So we have this as the x-axis of, we captured that. This curve here represents y is equal to x squared minus 3x plus 6. And then we have the line x is negative 2 right here. X is negative 2. And then this line here was the x is equal to 8. So the area bounded by the curves is this part I'm shading. And that is what we found its area to be, 150 square units. Next, we are going to use the mid-ordinate rule with 5 strips. So we are still going to have the sketch that we had earlier on. So this is negative 2, 0, 2, 4, 6, and 8. But this time round, we are looking at the mid-ordinates. So for the mid-ordinates, look at the mid-ordinate here. We have between negative 2 and 0, the midpoint is negative 1. Then here we have 1. Here we have 3. Then 5. And finally, we have 7. So we're interested in the mid-ordinates, where if x is negative 1, then you get the value of y. Then y when x is 1, y when x is 3, y when x is 5, and finally y when x is 7. So for the mid-ordinate rule, area is equal to h, that is the width of each strip, into the sum of the mid-ordinates. So we have y1, rather y negative 1 plus y1 plus y3 plus y5 plus y7. So h remains the same because we determine it the same way we determined for the trapezium rule. So the area becomes h, which is 2, into y when x is negative 1, so that is 10, y when x is 1, that is 4, y when x is 3, that is 6, plus y when x is 5, that is 16, plus y when x is 7, that is 34. So with all this, when worked out to get 140 square units as the area. Finally, by integration, determine the exact area bounded by the curve. Y is equal to x squared minus 3x plus 6. The lines x is negative 2, x is 8, and the x-axis. So here we are going to use integration. So the area becomes, so we integrate the function y is x squared minus 3x plus 6 in the limits negative 2 and 8. So we integrate that with respect to x, so that upon integrating we will simply have, this is x cubed over 3 minus 3x squared over 2 plus 6x plus a constant c. So that is within the limits negative 2, 8. So what we're simply going to have next is, we are going to substitute for 8 in the first bracket, so that we have 8 cubed over 3 minus 3 over 2 into 8 squared plus 6 into 8. So finally c will disappear. So even if it doesn't feature here, it's not a big deal. Minus the second part, we have negative 2 being substituted for x. So we have negative 2 cubed all over 3 minus 3 over 2 into negative 2 squared plus 6 into negative 2. So that the first bracket gives us 122 and 2/3, and the second bracket gives us 20 and 2 over 3. So that when this is summed up, we simply get 143 and 1/3 square units. Well, it's worth noting that the integration method determines the exact area. So you can see trapezium rule and the mid-ordinate rule are estimates. So they are somewhere close to the exact value. That's it for this question. Thanks for your patience. Thank you for watching. See you next time.